In this lesson we're going to continue to look at electromagnets. We learnt in the last lesson that you can make an electromagnet by winding a conducting wire into a solenoid or into a coil. Okay, so what we're doing is we're forcing an electric current to flow around a series of loops. That's what a coil is, and as a result of that a magnetic field is produced similar to that produced by a bar magnet. So you have a north pole at this end and a south pole at this end, and we call this a solenoid. Now the magnetic pole produced at either end depends on the direction of the current flow, so if we reverse the current then we reverse the poles of the solenoid. Now we also learnt that the strength of the magnetic field depends upon the size of the current that's flowing in the coil. So the magnetic field strength can be increased by increasing the current that flows in the coil, and also by increasing the number of turns in the coil. So if the coil is wound really tightly with lots of turns, then it will produce a stronger magnetic field than if the coil is wound loosely with fewer turns. But even doing that, at the moment the strength of the magnetic field produced by this particular solenoid isn't going to be very great. There is one thing that we need to do to really enhance the strength of this magnetic field and to make this a really useful electromagnet, and that is by inserting a magnetic material into the core of the solenoid. So let's just do that. We're going to insert a soft iron core into the solenoid and turn it into a useful electromagnet. Okay, so there's our electromagnet, and the advantage of an electromagnet is that I can turn the magnet on and off. Right, so what I do is I close the switch like that, and immediately I create an electromagnet with a north and south pole. That can then be used to pick up objects that are made from magnetic materials such as iron or nickel or whatever, and as soon as I open the switch the magnet loses its magnetism and the objects will then drop to the floor. So to ensure that this happens, you need to make sure that the core of the electromagnet is made from a magnetically soft material. And a magnetically soft material is one which can easily be magnetized and also easily demagnetized. The ideal material for this purpose is soft iron or wrought iron. Now you wouldn't use, for example, steel as the core of the electromagnet, because steel tends to retain its magnetism once magnetized. So when you open the switch you'll still find that there are things clinging on to the steel core, which you don't want if you're using your electromagnet to transport things from one place to another, for example, as in a scrap metal yard.